All right, get this. Imagine building an AI, but not just any AI, one that can manage a city's entire power grid.
Whoa, now that's a tall order.
Right. It's not just about the numbers, crunching numbers. It's got to predict demand.
And optimize distribution, right?
Exactly. And react on the fly, like if there's an outage. Even negotiate energy prices. Can you believe it? You'd need a whole team of AI, each one a specialist working together.
Like a well-oiled machine.
Boom. You get it? That's LLM multi-agent systems, people.
See, this is why I love this field. It's not just one AI trying to do it all. It's like, how can AI work together?
It's AI teamwork.
Exactly.
Okay, so let's break it down. Start simple. We need to predict how much energy the city's going to use.
Okay, so you might have an AI for that. One that just looks at the weather, historical data. Another one laser focused on like social trends,
Yeah.
are people staying home, going out, that kind of thing.
Interesting.
And of course, got to have one crunching the economic number.
Right, because if the economy's booming, more energy use.
Exactly.
Okay, so we've got our data specialists. They're feeding it all to what? Like a main AI.
Yeah.
An AI manager.
You're on the right track. That's what we call an equal-level system.
Equal-level.
Yeah, it's like a team. Everyone's equal. No one's the boss.
So our AI specialists, they're all just working together, sharing what they know.
Exactly. And that works great for this kind of thing, predicting energy use, because you need all those different perspectives.
That's like a diverse AI team.
I like that, yeah. Diversity of data, diversity of AI, it all matters.
Okay, that makes sense for like figuring out the data.
Yeah.
But what about actually making the decisions? Like it's a heat wave, energy demand is through the roof.
Oh, yeah, that's a good one. So let's say we have an AI agent, and its only job is to keep the power grid stable.
Okay, so it's like watching the energy flow.
Exactly. And it can see, oh, this area is about to overload, got to do something.
So it can make decisions, like turn off power to some places so the whole thing doesn't go dark.
Now you're getting it. That's a hierarchical system. You got your expert AI making the tough calls.
Like an AI air traffic controller.
Aha! Love that analogy. Keeping everything running smoothly, even in a crisis.
So cool. But things get even more complex, right?
Oh, you know it.
What if our city has all these smaller power grids, like each neighborhood has its own little system?
Microgrids.
Yeah. So it's not just one big grid anymore.
Exactly. Now, you could have a team of AIs managing each microgrid, keeping things efficient on a local level.
Okay, that makes sense, but they still need to talk to the main grid, right?
Yeah.
Make sure everything works together.
You got it. And that's where it gets really cool. We're talking teams within teams now.
Whoa, so an AI managing other AIs.
That's a nested system for you. Local control, big picture coordination, essential for these complex situations.
Okay, I'm starting to see how each system brings something different. But the world changes fast, right? What about when a natural disaster hits?
Ah, now you're thinking like a true AI architect. Okay, so picture this. You have an agent, and this agent, it's the disaster specialist. It may not usually call the shots, but...
But when a disaster strikes, suddenly this AI is the leader.
You got it. Dynamic systems, baby. They adapt, they change, roles shift, new agents come in. It's like AI improvisation.
That's wild. So it's learning as it goes, dealing with whatever gets thrown at it.
Exactly. Seeing the potential now. Multi-agent systems, they're the future.
Definitely powerful stuff. But, and maybe this is obvious, isn't it hard to actually make this work? I mean, getting all those AIs on the same page?
You've hit on the million-dollar question. It's not just about the what of multi-agent systems, but the how. And that's where the really exciting research is happening.
Okay, so what's the holdup? What's making this so tricky?
Two big things, planning and memory. Those are the hurdles we got to clear.
So planning. It's got to be more than just giving each AI a to-do list, right?
More. Okay, picture this. Same power grid, but it's a heat wave. You got one agent. It's all about saving energy, max efficiency.
All right, got to keep those bills low.
Then you got another one. Its job is to keep the grid stable, no blackouts.
Essential.
Oh, and we can't forget costs. Got an AI for that too, trying to keep things affordable.
Okay, so 3 AIs, 3 goals, but those goals, they might clash, right?
Bingo! What's the most efficient might not be the most stable, and the cheapest option might not be either of those things.
So how do they decide? Who gets to make the call?
That's the question. It's like a three-way negotiation. Every AI wants what's best for its goal, but they got to work together. And that's where game theory comes in.
Game theory. Like AI is playing poker with our electricity.
Kinda. It's about understanding how these agents can negotiate, compromise, find the best solution for everyone. It gets pretty complex, but that's the challenge.
Wow. Okay, so planning is complicated. But what about memory? I mean, AI and memory, that's like a whole other thing.
Huge. Think about it. Our power grid AIs, what if they could remember every heat wave, every blackout, every time they saved the day?
Experience, like, they've seen it all. That'd be incredible.
Right. But how do we give AI that kind of memory? It's not just data, it's understanding what happened, why it happened, what they learned.
So, like, an AI with actual wisdom, not just information, how's that even possible?
That's the big question. We're talking about representing knowledge, cause and effect, all that stuff we humans just kind of know.
Intuition, gut feelings, all that.
Exactly. And on top of that, you got to think not every AI needs access to everything. It's like in a company, right?
Need-to-know basis,
Yeah.
right.
Exactly. So we have something called memory access control, basically deciding which AI gets to know what.
AI secrets.
Kind of. Keeps things organized, keeps things secure. And then there's this whole other level, episodic memory.
Okay, that sounds new. What's episodic memory all about?
It's not just remembering what happened, but the whole experience. Imagine these AI agents, they remember past collaborations, when things worked, when they failed, and they learn from it.
So the next time, they're even better, smarter, because they're working together and remembering it all together.
Now you're getting it. It's collective intelligence, evolving over time. And this leads us to something really cool, a real-world application, blockchain technology.
Blockchain. See, now you're speaking my language.
Yeah.
But seriously, how does this all connect to multi-agent systems?
All right, so imagine this. Two companies, right? Huge companies, global. They want to make a deal, a trade agreement, but it's complicated.
Yeah, I've been there. Lawyers everywhere, paperwork for days.
Exactly. But what if, instead of all that, they each had their own AI, like a super-powered legal team, multi-agent system, trained on every trade agreement ever?
Wait, so these AIs, they're like writing the contracts.
Even better, they're negotiating, analyzing the terms, spotting loopholes, making sure it's all above board.
No way the AIs are arguing over the contract.
Well, not arguing, more like finding the best solution for everyone. And because it's all on a blockchain.
Right, so everyone has a record of it. Transparency.
Exactly. No more shady deals. Everything's trackable, auditable, more efficient, way more trustworthy.
That's huge for global trade. But what about other stuff? I'm thinking supply chains, making sure products are real, all that.
You're right on the money. Think about it. Every product, your phone, your coffee, everything has its own little digital passport on the blockchain.
And the AIs are checking them at every step.
Exactly. No more fake sneakers, no more wondering where your package is. And it gets even better. Think sustainability.
Okay, yeah, because right now, global shipping, it's a mess.
Right. AI agents could optimize everything. Routes, packaging, you name it. Less waste, faster shipping, happier planet.
And probably saving companies a ton of money too, right?
Exactly. And then it gets really wild. What if, and this is where it gets really interesting, what if each blockchain node was its own AI agent?
Whoa, hold on, back up, what do you mean?
So right now, a node, it's just storing information, right? But what if it could act on that information, make decisions, communicate?
So instead of one big authority running the blockchain, it's like a whole network of AIs working together.
You got it. Decentralized, democratic. Think of the possibilities. Especially when those AIs have the power of LLMs, they can talk to each other, learn from each other.
That's a whole new world.
Yeah.
But where does that leave us, the humans?
Ah, the big question. And it's one we need to be asking. As we build these systems, we got to make sure they're reflecting our values, our ethics.
It's not enough to just build cool tech. We got to make sure it's good tech, right?
Couldn't have said it better myself. The future of AI, it's not just about algorithms and data. It's about us. What kind of world do we want to create?
Deep stuff. Well, listeners, if your brain isn't buzzing after that, I don't know what to tell you. This is the future, unfolding right in front of us. LLM, multi-agent systems, blockchain, it's all connected, and it's all about to change everything. Until next time, keep those minds open,